career in software development and have been at both Amazon and AWS, and now I'm with AWS Robomaker for the education. Emily?
Hi, yeah, I have a background in web development and also working at web development startups. From there, I moved to AWS and was lucky enough to be one of the members of the founding team for Robomaker, and it's been fun getting to work with Jack, to work with students all over the world, helping teach and explore the area of cloud robotics.
Great. So before we jump in together, Emily and I are Robomaker's outreach to students, educators, and researchers. So let's get started with a question. Why did we build Robomaker? The pattern we saw for a while was that in speaking to customers trying to build robotics applications is that it's pretty hard. In many cases, there is significant machine learning experience required to build a robot. There are many prototyping iterations. So much like any product development cycle, you define some baseline, you build it, you test it, and repeat until you're satisfied with the output. There can be days spent setting up and configuring the environment. The robotics development environment could be complex. There are lots of different software tools and different hardware to run them. And after that, it can take months to build a realistic simulation environment, which is a key success factor in robotics. Very large part of robotics development is simulation. Before you spend a lot of money on the physical hardware, you want to simulate the robot's behavior to ensure software will work as required when it gets translated to the physical world. And lastly, there are a lot of duplicated efforts integrating an application management system, which is where the software is deployed to the robot. These challenges can take significant time and effort to overcome. And much of this work usually adds very little value to the application that the developer or the student educator is learning to build or building. At AWS, we call these efforts undifferentiated heavy lifting. And this can rob time from the developer, the educator, or the student, leaving less time to actually build, or in the case of a student or an educator, focus on learning objectives. Robomaker eliminates these challenges and accelerates the end-to-end development of robotics applications, so developers have more time to innovate. We see this as a game changer for robotics because a developer is no longer limited to the physical compute and memory and resources on the robot, no longer limited to the ML or analytics, excuse me, or monitoring they can code in the robot. Instead, they can take advantage of cloud services. AWS provides a service which makes it easy for developers to develop, test, and deploy robotics applications at scale, and as well as build intelligent robotic functions using AWS cloud services. Robomaker is a suite comprised of 4 independent yet integrated components. The first is a robotics development environment in the cloud. And that's built on a robot operating system called ROS, R-O-S, ROS, and I'll use that term throughout this presentation. The second is a cloud extensions for ROS, which extend the ROS framework to connect to AWS services. Third is a fully managed simulation environment capable of large-scale parallel simulations and testing. And the fourth is fleet management, which supports over-the-air application development to the physical robot or fleets of robots. And I'll provide details on each of these in the following slides. But first, let's talk a little bit about robotics and education. From the 1966 creation of Shaky was the first modern mobile robot, to 2007, when ROS was created and used in university classrooms, research labs have created leading hardware platforms, algorithms, tools, and best practices for robot development. If we fast forward to today, robotics courses in higher education and even K-12 are becoming increasingly popular. Robotics is beginning to evolve from a focused niche discipline to a computer science and engineering disciplines. We've even seen robotics starting in elementary school. If you're not familiar with ROS, like I said, it refers to the robot operating system, which is a flexible framework for writing robot software. It's a collection of tools, libraries, and conventions that aim to simplify the task of creating complex and robust robot behavior across a wide variety of robotic platforms. Way over on the right of that slide, you can see pictures of the Turtlebot Burger, the Sphero Bolt, and the Canova Gen 3 robotic arm. So the benefits of AWS Robomaker for education. For educators, a big task is setting up student desktops. Typically, educators have to configure servers and desktops to run software. With Robomaker, there's no infrastructure to provision. It's included with Robomaker, and nothing needs to be deployed locally. AWS Robomaker offers intelligence out of the box. So those cloud extensions I mentioned previously provide developers pretty easy capability to implement machine learning services into their robot applications. Hardware is optional. Not every learner has access to a robot, or maybe a robot is shared amongst a large group of students. With the managed simulation environment in Robomaker, students are able to test their robot applications in simulation first. We provide a number of pre-built simulated worlds for students to use, as well as an apartment, bookstore, and racetrack. Let's take a deeper dive into each of these components. As I mentioned a few slides ago, provisioning development desktops, downloading OSs and robot software frameworks, and installing and configuring tools is just wasted time and effort, and a prime example of undifferentiated heavy lifting being performed in university classrooms, research labs, startups, and larger businesses working with robots. Repeating these actions is taking time away from learning and innovating with robots. Robomaker's development environment is a customized environment in AWS Cloud9 IDE. IDE stands for Integrated Development Environment for robotics development. This environment comes with ROS pre-installed and includes sample applications. This environment is also integrated with other Robomaker capabilities such as simulation, so that you can use these capabilities from the interface of the development environment. Many of the packages that a typical robotics developer would need to install in their development environment have already been pre-configured and deployed in this environment. Here's an example of robotics application development workflow. This workflow can apply to any ROS robot serving a variety of commercial and home applications. AWS Robomaker supports this workflow. We spoke about the Integrated Development Environment, or IDE. Here's a screenshot of the Cloud9 IDE, which I'll log into in a few minutes, and I appreciate this is a little small. But AWS Cloud9 is a cloud-based IDE that lets you write, run, and debug your robot application within a browser. It's a prepackaged with tools required for robot application development, and since it's cloud-based, you can work on your projects wherever there's Wi-Fi. While we're here, looking at the directory structure on the left, you get a feel for the anatomy of a robot application. The nodes, files shown in the middle under the nodes folder, are central to the architecture of ROS robot applications. A node is a process that performs computation. Nodes are combined together into a computational graph and communicate with one another using streaming topics, RPC services, and the parameter server. A robot control system, which is running inside the robot, will usually be comprised of many nodes. For example, one node controls a laser rangefinder, another node controls the robot's wheel motors, and another one would perform localization, path planning, and so on. The second component of the Robomaker suite are cloud extensions for ROS. Developers are constantly working on ways to include more intelligent functionality in their robots, but are limited by the physical compute and memory resources of the robot and cost and expertise. With AWS Robomaker's cloud extensions for ROS, we've enabled access to everything from machine learning to our analytics services to monitoring. We don't want developers to have to learn how to use an AWS service or to have a secure connection or how to encrypt data before putting it on the wire or perform authentication. We've wrapped all that logic up. It's all open source and you can see what we've done. What we present to you are ROS nodes, small programs in ROS terms that you can choose from. And we've included sample applications accessing each service, which are all open source. Simulation is extremely popular and widely used in robotics development because it's extremely hard and costly to test on real hardware, especially in large classes of students or development teams. Robomaker's third component is simulation. The Gazebo Simulation service is a robust simulation suite that can virtualize 3D environments of various kinds. It comes pre-programmed with several models, including a retail store and a warehouse. You can spin up the Gazebo simulation to test your application end-to-end to generate synthetic data over what your robot sensors might be seeing. You do not have to provision any hardware. We automatically scale the simulation resources depending on the complexity of the simulation. You can run multiple simulations in parallel. If you're doing regression testing, we can scale out to thousands of simulations running in parallel for a single account. Here are some views of the simulation console, and we'll see a running simulation in a few minutes. Gazebo, shown on the left, lets you build 3D worlds with robots, terrain, and other objects. It also has a physics engine for modeling illumination, gravity, and other forces. Robotics developers use Gazebo to evaluate and test robots in different scenarios, oftentimes more quickly than using physical robots in scenarios. Gazebo also makes it easier to test other aspects of your robot, like air handling, battery life, navigation, and machine learning algorithms. RQT, shown on the right, hosts a number of different plugins for visualizing ROS information. Multiple plugins can be displayed on a custom dashboard, providing a unique view of your robot. RQT includes many useful plugins and provides a framework to write custom plugins. RQT provides a plugin to help visualize data from a robot. The image data is updated as the robot moves in the simulated world. We've talked about the cloud-based and development environment, the extensions and simulation and model and training. As a developer, after iterating through dev, test, simulation cycles, your application is ready for deployment to your robot or fleet of robots. Building your own proprietary application development system is undifferentiated heavy lifting. AWS would rather manage that for developers, so developers can focus on innovating their core robotics application. The fourth component comprising Robomaker is fleet management, which provides over-the-air deployment capability integrated with AWS IoT Greengrass. In addition to over-the-air application deployment for Robomaker, AWS IoT Greengrass provides security. Nobody will be able to push code onto your robot without your AWS credentials. You'll have a registry so you can register your robot, join it to a fleet, and manage collections of robots. The service even includes an agent on the robot, which determines the best time to deploy code to the robot. Let's look at the Cloud9 IDE in more detail. We have our directory structure on the left, shown here. Our file editor is on the right, and tabs for the Linux terminal windows are at the bottom. Looking more closely at the directory structure, you'll notice the robot.ws folder here, which contains all the code running on the robot. The simulation workspace here folder contains code for the simulation environment. As I mentioned before, the node files shown here contain the code controlling the sensors, actuators, or processing within the robot. If we actually open a node here, we can see rather typical Python program shebang with the path of the Python interpreter. You'll get into importing the libraries, and then actually Python code here, definition of classes and so on, with then calls out to the ROS SDK. If you look further down here, CMake lists is the instructions for actually how to build the application, and then package XML defines all the libraries and dependencies that are part of the robotics application. In the interest of time, I've built and bundled the application and loaded it into Gazebo for testing. For anybody developing a robot application, being able to simulate the robot's behavior helps speed the application development process while eliminating the need for a robot during early test cycles. I have the Gazebo Simulator running on the left, and as you can see, this is our apartment world. And if you look very closely here, we can see our robot moving throughout the apartment. On the right is RQT, and what's interesting here is RQT is getting the video feed from the robot's camera sensor, so that raw image video is being processed by the camera node on the robot, putting it onto a ROS topic or publishing it onto a ROS topic, and then actually we can see the traffic across that topic. For example, this topic could actually publish into another node that is doing ML modeling, and it could look for an image in this apartment and actually do processing related to that image. So at this point, I'm going to hand the presentation back to Tiffany for questions.
Thanks, everyone. And thank you so much, Jack. That was really informative. So we got some really great questions from a lot of participants ahead of the webinar, and I tried to bucket them into repeating questions that I saw a lot. So we'll just go ahead and start with those. For Jack or Emily, first question, can a non-programmer learn AWS Robomaker, or does it require intermediate programming skills?
That's a great question. AWS Robomaker leverages the robot operating system ROS. The ROS framework is easy to implement in any programming language such as Python and C++. And those are the primary languages supported by ROS. That said, having a proficiency in Python or C++ will help you be successful using AWS Robomaker.
Awesome, thank you. The next one, a lot of people were asking, can I use Robomaker with an AWS Educate Starter account? And the answer is yes. It is compatible with the AWS Educate Starter account, as well as classrooms if you have an educator that's using the Robomaker template for a class. So for the next question, people were asking about applications in other fields. So does this program have an application in the field of electrical engineering?
I'd say it does. What we've learned in talking to professors, educators in many different universities and colleges is robotics itself is a multidisciplinary area, and it combines electrical engineering, mechanical engineering, and computer science. And this area includes embedded programming, control systems, automated decision-making, and power electronics. So all these disciplines have to work together to sense, think, and act, which is really what robots do. So yes, the answer is yes. It does include electrical engineering.
Awesome, thank you. People were asking, how can I get my Robomaker badge after completing the webinar? The badge is available to you in the AWS Educate student portal. But again, updates to the curriculum are forthcoming. Those should be coming between July and September. So you'll be receiving an email with that update when it comes, but also check out the student portal. We post updates in there all the time. And one other quick note to mention is participants on this webinar will be receiving a certificate of participation following the webinar. It is being recorded as well, so you will be sent a link to the recording following the webinar. Next question is, how can I proceed if I want to excel in robotics and with automation with AWS? Jack or Emily, if you want to take that one.
Yeah, that's a really good question. I would say, first and foremost, this webinar is a great start. You've been exposed to ROS, you've been exposed to Robomaker. There are a lot of very, very good resources available. ROS is an open source framework that you can go to ros.org and read a lot about the ROS SDK, ROS tools, and so on. Likewise, with Gazebo. Also look to AWS Educate, and also, as Tiffany mentioned early on in this webinar, look for our cloud robotics curriculum that's scheduled to begin to show up soon.
Great, thank you. How can this tool be applied to different industries, especially in an increasingly remote world? I think that's a great question. We saw that one pop up a few times.
Yeah, that's a really good question. In a lot of the data that we're seeing, there are many industries that robots are being exploited in, but I'll talk about a few here. We're seeing that by 2025, robots will be there'll be a material deployment and usage of robots in medical and healthcare, and we're seeing a lot about that right now. Agriculture, consumer and household, automotive, transportation, and emergency and first response, and of course that doesn't mention the robots our own Kiva robots that we use in our warehouses. Supporting robots and their applications will be developed and maintained following a robotics application development lifecycle, which will be supported by Robomaker. So regardless of industry, if you go back to that robotic application development workflow, it's really industry independent, and the approach, the tools, and so on transcend all industries.
Thank you so much. I know you touched on this one before, but if we just want to revisit this, a lot of people are asking, what's the programming language used for Robomaker?
So if we go back to the sample nodes that I had shown you, that was Python. C++ is another very popular language that ROS supports. There are a few others, but I would say Python and C++ are the most prominent.
Thanks. And do you need to have a testing hardware or some kind of simulator to use this?
So no and no, but let me provide a little more color on that. AWS, as we've seen, is built on ROS. ROS is comprised of libraries and tools needed to build, debug, and test. The Gazebo Simulator is included in AWS Robomaker, so you can conceive of a robot, write the code, debug the code, run the code in a simulator, go through multiple iterations, seeing it in an environment before you actually have to put it onto a physical bot. So while a physical bot isn't included, there is a lot of excitement when that code eventually gets deployed onto that physical bot and that bot comes to life and does what it's intended to do. So I hope that answers the question. I did want to mention, there was an early slide about robots in education. There are a number of robots that are available at different price points that do support ROS, and you can find those online, and I urge you to take a look if you're seriously interested in robotics. You can find those robots and make that part of your development lifecycle.
Great. There were quite a few questions that came in about costs, so that one requires a little bit further research. And I will say, as members of AWS Educate, you all have preloaded credits in your student starter account that you can use to experiment with these services. And Jack, I don't know if you're able to say anything else about the cost of this service.
The cost
Generally.
of this service, well, I mean, as Tiffany mentioned, the service, the credits you receive through AWS Educate will cover generally cover the costs of AWS Robomaker for basically a semester, depending on on how your mileage may vary here, but generally it'll cover that. Maybe I'm reading into the question a bit more. You can get into a ROS-based robot for less than $300, and then spend multiples of that getting more advanced robots that have lots of capabilities.
Awesome, thank you. We're getting a lot of great feedback in the chat. Yes, if this is something people are still interested in, we can certainly do more webinars on this topic. Again, it is being recorded. You'll be sent a link and a participation certificate. And one final thing that keeps popping up, and I know you touched on this a little bit before, but I keep seeing this question: where do students go next? There's incredible amount of interest in this group in getting started and getting hands-on. So after this webinar, if they're just dying to get started, where should our students go? Besides the AWS Educate portal, of course. But any recommended reading or anything like that?
Yeah, I would think, we talked about proficiency in Python or C++. So there are multiple resources online that can help you out with that. So that's number one. Two is begin to research ROS. ROS.org is a great place to start. There is lots of different information about ROS and its tools, libraries, and use within ROS.org. At that point, you could come back into AWS Robomaker, leveraging some sample code and actually get going, and looking at a sample app, beginning to go through lines of code, understanding how the calls are used and what they're doing and how they're controlling the behavior of the bot in the simulator.
Great, thank you so much. And thank you everyone for joining. We hope that this was a great start for you all to get interested and get started with Robomaker. Again, if it's something that people want more of, we can certainly do more webinars around this topic, and we can't wait to hear from you guys and see what you build next. So thank you so much, everyone, and enjoy the rest of your day. Thank you, Jack and Emily.
Thanks, Tiffany.